If you take off your helmet on Mars, you won't freeze first. You'll suffocate from lack of oxygen. The pressure here is so low that your saliva and bodily fluids would boil instantly. Sitting in the same habitable zone, yet the atmospheres of these two worlds couldn't be more different. Earth enjoys a thick atmospheric blanket, creating the perfect pressure to sustain life. Meanwhile, Mars' atmosphere is 100 times thinner, fragile and razor-thin. This drastic contrast leaves Mars with an average temperature of -62 degrees Celsius.
Let's start with the most fundamental element, the gases that make them up.
Earth's air consists of roughly 78% nitrogen and 21% oxygen. In stark contrast, 15% of the Martian atmosphere is toxic carbon dioxide. Free oxygen on Mars accounts for less than 0.15%. That means you couldn't take a single breath here on your own. You might wonder, with so much CO2, why isn't Mars blazing hot like Venus? The reason is simple. The total mass of Mars's atmosphere is far too small and sparse.
Day-to-night temperature swings on Mars can span nearly 100 degrees.
A thin atmosphere also drastically changes how sound moves through space.
Your voice on Mars would sound lower, muffled, and wouldn't travel far at all.
Chemically speaking, where Earth is abundant, Mars is utterly barren.
The second equally dangerous factor is surface atmospheric pressure.
Barometer at Earth sea level, 1013 hectopascals gettable. At Earth sea level, average pressure reaches 1013 hectopascals.
On Mars, that number plummets to roughly 6 hectopascals, less than 1%. Mount Everest graphic. Peak pressure is 1/3 of sea level. Martian pressure is equivalent to standing 35 kilometers above Earth. That's way past the Armstrong limit, a deadly biological threshold. Below this threshold, water boils at human body temperature, 37 degrees Celsius. Earth's dense atmosphere also serves as a magnificent friction shield.
Thousands of small meteoroids disintegrate every day before ever reaching the ground.
On Mars, thin air lets space rocks slam directly into the surface, unchecked.
Landing spacecraft on Mars is notoriously tough due to the lack of air resistance. Atmospheric height graphic. Earth extends up to 10,000 kilometers, yet because of weaker gravity, Mars' atmosphere extends relatively higher up. Martian gravity is just 38% of Earth's, struggling to hold on to gas.
Low pressure also severely weakens the physical force of the wind.
100-kilometer-per-hour gust on Mars feels like a light breeze on Earth. Summary graphic of pressure and density. Low pressure remains the single biggest obstacle to human colonization.
Next, Let's look at protection against cosmic hazards.
Earth's ozone layer blocks 99% of harmful ultraviolet radiation. Mars completely lacks an ozone layer, exposing the surface to raw radiation.
Despite thin air, Mars harbors terrifying planet-wide dust storms. Enveloping dust storm blocking all sunlight for months. Fine dust gets kicked up, blotting out the sun completely for months at a time.
These storms have disabled multiple solar-powered rovers over the years.
Electrostatic Martian dust clinging tightly to gear. Martian dust is toxic with perchlorates and carries a high static charge.
Rain cleanses Earth's atmosphere, but Martian dust floats endlessly.
Clouds on Mars are extremely rare, composed mostly of dry ice crystals.
Interestingly, atmospheric dust gives Martian sunsets a distinct blue glow. Clearly, Mars' protective shield is practically non-existent against deep space.
The big question: why did Mars lose its atmosphere in the first place?
Geological evidence shows 4 billion years ago, Mars had flowing water and thick air. The secret lies deep within. Earth has a molten iron core spinning continuously. This dynamo generates a powerful magnetic field, deflecting charged solar wind particles. Smaller Martian core gradually cooling down and freezing solid. Being smaller, Mars cooled faster. Roughly, as the core stopped spinning, Mars' protective magnetic shield collapsed.
Defenseless, solar wind ripped away and stripped the atmospheric gases into space.
NASA's MAVEN mission confirms Mars is still losing gas to space every single second. As pressure dropped, surface water evaporated or froze into underground ice. Earth maintaining its active molten core driven by radioactive decay. Earth stayed lucky. Powered by core size comparison, Earth's large core versus Mars' small core. Size dictated destiny. Mars was simply too small to hold on to its inner heat. A once promising world transformed into the frozen desert we see today. Losing its magnetic field was the ultimate death sentence for Mars' atmosphere.
Could humanity ever restore Mars' atmosphere in the distant future?
Some propose detonating nuclear weapons at the poles to melt trapped CO2 ice.
Giant orbital mirrors focusing sunlight onto Mars's surface. Or
NASA calculations, total polar CO2 only raises pressure by 7%. However, NASA studies reveal there isn't enough total CO2 to build adequate pressure.
More importantly, without an artificial magnetic shield, solar wind would just strip it again.
For now, living inside sealed, pressurized domes remains our most realistic path. Looking at Mars' harsh reality reminds us just how priceless Earth really is. Earth's atmosphere is a natural masterpiece that no technology can replicate. Protecting our atmosphere here on Earth is protecting our very survival. What do you think about human colonization of Mars in this century?
Thanks for watching, and check out the recommended videos on your screen.
See you in the next scientific journey.